Hello, I'm Caitlin Rodriguez Rivera, and this is my Physics 2212 Lab 6, Magnetic Molasses. The purpose of this experiment is to collect observational data of a magnet falling through a conductive copper tube before modeling the interaction computationally and comparing the computational predictions with the observed data, along with the results of the experiment and computational models. Some fundamentals include the Biot-Savart law, which determines the magnetic field generated by a small, constant current-carrying conductor for the distance between the source of the field and the Ops location, along with Faraday's law, which states that the changing magnetic field through a coil of wire induces a voltage called electromotive force. The induced voltage is directly proportional to the rate of change of magnetic flux and number of turns in the coil. Some additional fundamentals are Newton's second law, which states that the net force acting on an object is directly proportional to its acceleration and mass, and Newton's third law, which states that for every force in nature there is an equal and opposite reaction. In experiment 6's setup, the system is the bar magnet and the copper tube. The surroundings include everything in the near vicinity, and some initial conditions are: for the magnetic field of a bar magnet, the bar is treated as a point dipole, and the conductive tube is modeled as a stack of non-interacting conductive rings. For the procedure, some materials needed are a bar magnet, a smartphone, the copper tube, and a meter sticker ruler. The setup involves marking the north pole of the bar magnet using the magnetometer app from Lab 3. For experiment 6's procedure, using one hand, hold tube vertically and position magnet just above the top opening. Holding the smartphone in the other hand or with the assistance of a partner, get the entire length of the tube and frame. Record the magnet enter the top of the tube and leaving the bottom on video, scrolling through the video to find the time codes when the magnet enters the tube and when the magnet exits the tube. Calculate the time it takes the magnet to fall through the length of the tube before repeating 5 times and calculating the average time it takes. Here are the tabulated values recorded for our 6 trials, along with the average length of time taken between all 6 trials. Along with the tabulated time values, the mass of the bar magnet was 0.023 kilograms, its mu value was 3.9946 amps meter square, the length of the tube was 0.915 meter, its width was 0.006 meter, and its inner radius was 0.0254 meter. Here are the physical constants, graph initialization, and bar magnet components of the GlowScript code. Here is the copper tube component of the GlowScript code. Here are the initial conditions, the magnetic field of the bar magnet, and magnetic flux components of the GlowScript code. And finally, here is the simulation loop component of the GlowScript code. Here are the results, including a velocity versus time graph and a visualization of the bar magnet traveling the length of the copper tube. Some model assumptions made were negligible air resistance, the only forces at work being magnetic and gravitational, and the bar magnet behaving as a magnetic dipole, applying the Biot-Savart law. Some potential sources of error include other sources of magnetic fields distorting the measurements, possible friction against the sides of the tube not implemented in calculations, and inconsistent stopwatch timing. What if the resistivity of the conductor were reduced as close as possible to zero? How would the dynamics of the falling magnet change? The induced current present in the copper tube would be much larger due to Ohm's law, which would create a larger magnetic force on the bar magnet and possibly counteract with the gravitational force at work, preventing the bar magnet from falling. What if holes or slots were cut into the tube? How would this affect the ring currents in your model? This would impact the ring currents in the model since the induced current in the copper tube would be reduced because of the holes disrupting the current, making the magnet fall through much quicker. Thank you.